Greetings and welcome to Week 4, Unit 1 on knowledge categories. We are particularly interested in what we call as general categories of knowledge. In the last week, we understood and explored the nature of 6 cognitive levels of revised Bloom's taxonomy, and we attempt to understand the nature of 4 general categories of knowledge. We have already mentioned in the last week that revised Bloom's taxonomy is of 2 dimensions. The cognitive domain is characterized by 2 dimensions: cognitive levels or cognitive processes. The other one is knowledge. A third dimension can be added to address the depth to which the outcomes are addressed. So that we call as difficulty. This will be taken in more detail in an associated course on assessment. Knowledge, there are several words like this where until you want to formally define, you seem to be quite comfortable in using that word. Knowledge is a word that we keep using, but really get into issues when you want to define. For example, people have been trying to define what knowledge is for the last several thousands of years, and they haven't come to any conclusion as yet. So, the problem of characterizing knowledge is an enduring question of philosophy and psychology. We do not make an attempt to come to any conclusion either. So, we do give an operative definition for our purpose. That is, in the context of, let's say, this course or this set of courses, we consider our knowledge is defined in constructivist, cognitivist tradition. That's it. We say this is what we are doing, and all the things that we do are justified in this framework. In this tradition, knowledge is dynamic, structured, context-bound, and constructed by learners through interaction with content, others, and their own mental models. So, your knowledge and my knowledge on the same thing are likely to differ. The cognitivist and constructivist tradition, knowledge is constructed and not transmitted. So you have to construct. If it is only merely transmitted, I'm only repeating, memorize and repeat it back. It is not mine. So I need to construct the knowledge. It is situated and contextual. It is in particular context and a situation that knowledge is valid. If either the situation changes or context changes, the kind of the knowledge may be slightly different. It is organized into mental schemas. It evolves and is revisable also. Our knowledge is not static, it keeps evolving. Mediated by tools and culture, and meaningful and purposeful. So, this is the nature of cognitivist constructivist tradition. So, there are 4 general categories of knowledge: factual, conceptual, procedural, and metacognitive. These are the ones that have been presented in the revised Bloom's taxonomy book of 2001. They only talk about 4 general categories. That means for all areas, all subjects, these are the 4 categories only are proposed. But what we feel when you come to some specific things like engineering or medicine or management or for that matter, even computer science, these four categories of knowledge are not sufficient. They, if you only stick to this, there is something about these disciplines you are likely to miss. About computer science, uh, social sciences, or management, the categories, any specific categories of knowledge relevant to those disciplines, people are still debating, and people haven't come to any particular conclusion. Whereas in the context of engineering, this has been debated quite heavily, and people, I would say, it is one person who came to some conclusion and proposed as a set of what do you call, identified the categories of engineering knowledge, and many people have, after several debates, approximately endorse these same categories. They may slightly differ, but will present one particular person's, namely Vincenti, the four categories in addition to the four general categories of knowledge. And these are fundamental design principles or concepts, criteria and specifications, practical constraints, design instrumentalities. Let us in this unit mainly address the four general categories of knowledge. First one is factual knowledge, which is fairly simple to understand. Factual knowledge refers to the basic elements, terminology, symbols, and specific details that learners must know to be acquainted with a discipline or solve problems within it. It forms the foundation for a deeper understanding and higher order thinking. Unless you have some facts with you in the form of this terminology, symbols, and specific details, you will not be able to deal with that particular subject. And this exists at a relatively low level of abstraction. There is no abstraction in this, really speaking. So there are two subtypes of knowledge in this. One is knowledge of terminology, like words, numerals, signs, pictures, and so on. Knowledge of specific details, including both descriptive and prescriptive data and elements. We'll presently see some examples of this. Terminology. You use certain words to mean something. So the terminology in every subject one needs to be familiar with. For example, signal to noise ratio, or low pass filter, VCVS, CCCS, power factor, polymorphism. These are all the words which have very specific meaning in different subjects. So these words and their meanings one has to be familiar with. Specific details. Boiling point of ethanol is 78.37 degrees centigrade. Semiconductor devices fail above 120 degrees centigrade. Standard brick size in India is 190 mm by 90 mm by 90 mm. Texas Instruments and Analog Devices are two semiconductor manufacturers making a wide variety of analog ICs. So as you can see, you can also include pictures, like I represent a diode by certain symbol. That picture one should be familiar with if you are working in the area of electronics. Now come to next one's conceptual knowledge. Concept is another word that all faculty feel very comfortable with, and Everyone will say in all discussions, concepts are most important and people have to understand them. But often in our experience with a large number of faculty, we found this is another word people use it and feel comfortable with, but yet when you want to formally define, they have difficulties. And the formal definition of a concept, if you take, a concept is a mental representation or category that groups together objects, ideas, events, and phenomena based on the shared characteristics, properties, or rules. Looks complicated, but not. For example, you take the concept of a tree. There are large varieties of trees, right? But when you look at it, any tree, you will immediately recognize that it is a tree. So that is when I call something a tree, I am not differentiating between a coconut tree or a mango tree or some other tree. For me, tree, the so-called set of trees, if I take, it has certain characteristics. Those characteristics are common for all elements of that particular set. I can take something like mango tree, that is also a concept because there are large varieties of mango trees, and I will, when I am calling something like a mango tree, I am not differentiating between one variety of mango tree and another variety. So I can keep on, I can, what do you call, I can narrow down my set or expand my set. Either way I can do, and each one, that group has a name, so that when I it's if you want to say concepts are abstract in that they omit the difference of things in their extension. That is the idea. And these concepts enable us to recognize patterns, organize knowledge, and make sense of experiences. For example, if I say living organisms or living things or organisms, if I take that, a mango tree and a human being also are elements of that. So I'm not differentiating between the two when I use the concept called organism. Okay. So concepts are also basic elements of propositions, much the same way a word is the basic semantic element of a sentence. What does it mean? I can use several concepts and I can relate one to the other and form a sentence that also become a conceptual knowledge. Conceptual knowledge, it includes knowledge of categories and classifications and the relationship between and among them. Schemas, mental models, or implicit or explicit theories, they all constitute conceptual knowledge. The schemas and models and theories represent how a particular subject matter is organized and structured, how the different parts or bits of information are interconnected and they interrelated in a more systematic manner, how these parts function together. So, schemas will tell you that. Okay, let us look at some examples. If you look at individual concepts like force, acceleration, velocity, mass, equilibrium, voltage, current, temperature, entropy, stress, strain, recursion, these are all concepts, individual concepts. Then what happens is you can put a few concepts together, something related to voltage and current. For example, I can have Kirchhoff's current law. or a Newton's second law. I can have like that. Whereas if I put a set of these laws together, that becomes a schema or a theory, you can say. Okay, laws of thermodynamics. You talk about three laws of thermodynamics put together. Okay, so you can have at these three levels the conceptual knowledge organized. Then come the procedural knowledge. This is simple to understand. It is the knowledge of how to do something. Simple. Often takes the form of a series or sequence of steps to be followed. Includes knowledge of skills, algorithms, techniques, methods, collectively known as procedures. Any of these uh, procedures will constitute procedural knowledge. It also includes knowledge of the criteria used to determine when to use various procedures. One is a procedure, and the knowledge about when to use that procedure is also part of procedural knowledge. So, procedural knowledge is at two levels. One is a procedure, and the next one is when to use that procedure. And generally, the procedural knowledge is specific or germane to the subject matter or some academic discipline. You can say these are the procedures followed in mechanical engineering, like that. Same procedure may not be followed in electrical engineering. Okay, so they are specific to a particular subject. Some samples of procedural knowledge: solving a matrix differential equation, drawing a Bode plot, designing a filter as per specifications, performing a stress analysis on a beam, using GD and T, that is geometric dimensioning and tolerancing in civil engineering, designing a reinforced concrete slab, applying IS 456 code provisions, implementing a binary search algorithm, designing a responsive web page using HTML or CSS. Now we come to the fourth category of knowledge, namely metacognition. Initially, when of course, when handbook was prepared back in 1956, it was recognized, but it was not the importance of that was not known. But over a period of time, the role of metacognition is increasingly felt, and now we consider it's a very important element of knowledge. And faculty, if you want to facilitate all your students, because your students in a classroom are not uniform. Each one is a different person. So in such a case, the paying attention to metacognition becomes important in facilitating your students to learn. So what is metacognition? It is knowledge about cognition. That's why we use the word meta. In general, as well as awareness of and knowledge about one's own cognition. Or in other words, thinking about one's own thinking. Simple thing is, do I know this or do I not know this? At least you have to be clear. I know this or I do not know this. Then only I can take the follow-up action, right? If I do not know this, what is it that I need to do to know that? That also is part of how do I plan my activity to know that particular thing is also metacognition. So it is the ability to assess our own skills, knowledge or learning. So ability to assess itself is metacognition. A person's awareness of his or her own level of knowledge and thought process. That is a formal definition as given by Stephen Chu. A person's awareness of his or her own level of knowledge and thought processes. Metacognitive ability affects how well and how long a student studies. I'm sure as faculty, you would have noted that some of your students feel just spending 2 or 3 days before the final exam is adequate. And when they actually start preparing, they realize that time is not, that 2 or 3 days is not adequate, and they panic. And it also is part of how much and how deeply students learn. How much are you willing, because you think that you have understood something and don't put enough time on that. If you are aware to what extent that you know, then you will put more effort to know the additional things. So this awareness of your own cognition is crucial. And why should we be concerned about metacognition? Generally, high performing students have better metacognitive skills. It appears uh, the metacognitive ability is natural in some people, not adequate in some people, and perhaps even absent in some people. So, what happens if you want to improve the level of learning in your students? You have to make sure that you can assist him in his metacognitive ability. That's why we have one unit in the associated course on instruction for metacognition. Weaker students typically have poor metacognitions besides other things. If you compare high performing students and weaker students, high performing students have better cognitive abilities as well as better metacognitive skills. Whereas weaker students typically, besides other things, have poor metacognitive skills. So it looks like poor metacognition is a big part of incompetence. So if somebody you find incompetent to do things, the attention that you have to pay, how metacognitive, what is the level of his metacognition, and what are the things that you must do or make the student do so that his metacognitive ability improves. It can be improved. It is not as if you are just made that way. Okay, it can be improved. Students with poor metacognitive cognition skills will often shorten their study time prematurely, thinking that they have mastered course material that they barely know. So this I'm sure many faculty would have noted. They are grossly overconfident in their level of understanding. You read it once, yes, I have understood that, and keep it aside. And they underestimate or overestimate their performance in tests, make poor study decisions. I'm sure you would have noticed some students when they come out of the exam hall, they say, "Oh yes, I'm going to get 95% in this." Even some good students will also come out and say, "No, I barely pass," that kind of thing. The issue is poor metacognitive people with poor metacognition are likely to underestimate or overestimate their performance. So now, categories of metacognitive knowledge. Assessing the task at hand. When some task is given, can you estimate? Can you estimate based on the level at which you are? Can you estimate whether it is going to take 2 hours of effort or 3 hours of effort and so on? Assessing the task at hand. Evaluating one's own strengths and weaknesses. Yes, if I am aware of my strength and weakness, then I will be able to plan better. Planning an appropriate approach. What should I do? For example, I may consult somebody, or I may prepare myself by solving a lot of simple problems, or I have to go and study some book in the library, and so on. What is planning an appropriate approach? Applying strategies and monitoring performance. So you work out a strategy and implement that, and you keep monitoring yourself how far you have progressed. At some point, you should be able to say, yes, I have been able to understand something, but something else is also to be understood, and decide how much time it is likely to take. All these, many people do it intuitively, but metacognitively poor people are likely to make wrong estimates about this. Reflecting and adjusting one's own approach. After you try something, if it didn't work, you reflect on that, what has happened, and you adjust your approach. So reflecting and adjusting one's own approach is also one category of metacognitive knowledge. Beliefs about intelligence and learning. So if somebody says, yes, my genes are like that, what can I do? That's the way I am, kind of thing. That means there is a belief about your own intelligence. And say, however hard I study, I'm unable to learn. That is also a belief about your own learning. So metacognition can increase student engagement. That's the reason why metacognition is crucial. Metacognition has the potential to empower students to take charge of their own learning and to increase the meaningfulness of students' learning. So this is a very important element. Now, to capture the two-dimensionality of revised Bloom's taxonomy, as they acknowledge that learning, teaching, and assessment have three dimensions, or three domains of learning: cognitive domain, affective domain, and psychomotor domain. And cognitive domain has dimensions including cognitive processes, and they are, remember, understand, apply, analyze, evaluate, and create. And knowledge categories general. Why we call it general? They are applicable to all subjects, whether it is humanities and social sciences, just sciences, engineering. They are all applicable. Factual, conceptual, procedural, and metacognitive. When instructing, you are not dealing with knowledge elements belonging to only one group, one category. One may be dealing factual knowledge elements, factual, conceptual, and metacognitive elements, factual, conceptual, procedural, and metacognitive elements together. While the learner may not be directly dealing with metacognitive elements, the instructor has to deal with metacognitive aspects in designing instruction. That is where it matters. Okay. Now, in the next unit, we will attempt to understand the nature of engineering itself. And thank you for your attention.